In this video, I'd like to talk about multiplying monomials by polynomials using what we call an area model. So remember that a monomial is a one-term expression, mono meaning one, and a polynomial is a many-term expression, whereas poly just means many. So when multiplying these together, you can do it by using distribution, and that's one way that we can check these. But another way to multiply these together is by essentially finding the area of some rectangle. So you can see how this problem is set up. We have a rectangle that has a height of 6k to the third power, and it has a width of 2k squared plus 4k plus 5. And the product of this monomial by this polynomial will just be the area of this rectangle. And you're able to set up any problem where you're multiplying monomials or even binomials by polynomials as this area problem. So when looking at the specifics of this, we will take our height, the 6k to the third, and multiply it by each of the terms in the polynomial. And since there are three terms, we're going to get the area of three different rectangles. And once we find the area of each of these rectangles, we can just add them together to get the total area of the entire rectangle, which will be the complete product for multiplying this monomial by the polynomial. So let's just start going through and finding the area of each of these rectangles. So we have 6k to the third multiplied by 2k squared. So when multiplying monomials, remember we are just multiplying the numbers, the coefficients together first. So 6 times 2 is 12. And then we multiply the variables. So k to the third times k squared is going to give us k to the fifth power. Now remember, to understand that, there are two different approaches you can take. So let me work off to the side here. You can remember the rule that when you have x to the a and you multiply it by x to the b, when the bases are the same, you just add the exponents. So you can just remember that rule, or you can think it through with a specific example. So for us, we had k squared multiplied by k to the third. And k squared, if you remember the definition, we're multiplying this number that many times. So we're multiplying k twice. And k to the third, we're multiplying k 3 times. And so in total, you can count them, we are multiplying k 5 different times. But like I mentioned, since the base is the same, we could have just started by adding the two exponents together. Now let's move on to this red rectangle here. We're multiplying our height, 6k to the third, multiplied by 4k. And 6 times 4, we know that's 24. And k times k to the third, this is really k to the first power. We could add their exponents because the base is the same, so we get k to the fourth power. Or just remember we have 1k here, and we're multiplying it by 3 more k's here, and so in total, we're multiplying k 4 different times. So either way you want to think about it works. And lastly, we'll find the area of the green rectangle. So that's the height, 6k to the third, multiplied by 5, so 5 times 6, that is 30, and we still have this k to the third left over since there are no k's here. So our final answer for this, remember, we're just adding all of these rectangles together to find the area of the entire rectangle. So in the box, we'll put 12 times k to the fifth plus 24 times k to the fourth plus 30 k to the third power. And one way to check your work, the other way to multiply these together, is to use distribution. So let's check really quick with this. We have 6k to the third, and we're multiplying by this polynomial. That's 2k squared plus 4k plus 5. And with distribution, the 6k to the third is just going to multiply into all three of these terms. So 6k to the third times 2k squared, we're going to find the same answers, but it is good practice to do it both ways just to double check. So 6 times 2 is 12, k to the third times k squared we know is k to the fifth. 6k cubed times 4k. 6 times 4 is 24. K to the third times k is k to the fourth. And 6k to the third times 5 would just be 30. Let me make a little more room here. 30k to the third power here. So it's the same answer, like I mentioned, but practicing it both ways will help you feel a little bit more confident that you're doing these correctly. And some students do call this the box method, since if you're drawing this yourself, you can create a box, and we'll need to separate it into 3 different parts for its width, since we have 3 different parts for the polynomial. And of course, we know our height, that's our monomial, 6k cubed, and then each term in the polynomial gets one of these boxes. So 2k squared, 4k, and 5. So if you were setting it up by yourself, you would just draw a box and then separate it into however many pieces you need, depending how many terms you have, how many different things you're adding or subtracting. And one drawback of this method, which makes it a little bit confusing, and we'll see that in the next example, is sometimes you have negative terms here. And technically, you can't find the area of a rectangle when one of the side lengths is negative. Now, of course, we don't know what the variables are, so they could be positive or negative, and that can create some confusion. But this method will still work if you just ignore that physical fact. So even if this was -5, you can still apply this box method or this area model, and you will still get the correct answer for this.